Hi guys, Mrs. Brumwell here. We are going to go through some vocab for sections 1.2 and 1.3. We're going to cover these sections together. They have some very similar concepts. 1.2 focuses on segments and 1.3 focuses on angles. So we're going to kind of do this over a couple days, but we want to get the vocab for both segments and angles that we need for these two sections. So one thing we're going to talk about is congruent segments. So if we have congruent segments, they are the same length. And how we notate that in a figure is we actually use a tick mark. So if I use one tick mark here, I would use the same number of tick marks here. So that would let me know that these two segments are the same. I'm actually going to draw some endpoints on here too. And we'll call this one AB and call this one CD. So in my picture, I know those are congruent by those markings. So if this one had one tick mark and this one had two, that would actually let me know that they are not congruent. So they have to have the same number of tick marks. So if I put 2 and 2, that also is another way for me to know that those are congruent. Okay, so if they're congruent, so this is our symbol for congruent. It's like an equal sign with a little tilde or squiggle across the top. So it says if segment, notice my notation is a segment, if segment AB is congruent to segment CD, then, and this part's kind of weird, we're going to use AB and CD without the segment symbols, and I'm going to use an equal sign instead of congruent. So what this says, it says if these two segments are congruent, then their measurements are equal. So when we are naming the figures, we use the segment symbol and we use a congruent sign. When I'm actually talking about the measurements or their lengths, I use an equal sign. So if they're congruent, then they have the same lengths. That's what this means, okay? So length, an equal sign, no segment symbol. Congruent has the segment symbol, okay? If they're congruent, then their lengths are equal. I'm actually going to even write that down here, you guys. If they're congruent, then their lengths are equal. So that's what that says in words. Okay, we have a very similar thing with congruent angles. So if I want to show these angles are congruent, we can use these little arcs. You'll see this a couple ways. So I could see it like that. If they both have two arcs, that's another way I can show they're congruent. So if one of them had a single arc and the other one had two, I would know they're not congruent. Another way we'll see it, I don't usually use this one very much because I don't know, I just don't love it. But sometimes you'll see tick marks on there too. So that's another way to show they're congruent, or if they both had two tick marks. So there's a few ways to show congruent angles, okay? Okay, so notice I have my little M's here. So I'm gonna call this one angle D and this one angle A so that it goes with my definition here. So if the measure of angle D is equal to the measure of angle A, so this is saying if their measurements are equal, then I can say they are congruent. So if I'm saying they're congruent, I don't need the little M because we're not talking about the measurement anymore. I'm just talking about the figure. So I would say it's angle D is congruent to angle A. So this one kind of has it in reverse, but it's saying the same thing. If their measurements are equal, then they're congruent. If their measurements are equal, they're congruent. Okay? Okay, so anytime we use an equal sign, we do not, or equal sign for the angles goes with the measurement. Congruent does not. For segments, congruent goes with the segment symbol, equals does not. Okay, segment addition postulate. All right, so it's involving a segment, it involves addition. So what this postulate says, I'm going to put 3 points on here. I'm going to go ahead and call it A, B, and C. So what the segment addition postulate says is that if I were to look at these smaller segments and add them together, they have to equal the length of the whole segment. So for me, the length of AB, so because I'm talking about the length, I'm not going to use the segment symbol. So AB plus the length of BC has to equal the whole thing, AC. So anytime I use an equal sign, I don't use the segment symbol. So that is essentially what the segment addition postulate says. It says we can add the smaller parts to equal the whole thing. Pretty intuitive. Okay, the angle addition is the same exact thing. So if I were to draw a ray that kind of cuts this angle into two smaller angles, so I'm going to put some points on here so I can name these. So we'll call this A, B, C is the big angle, and then we'll put D on this ray. So if I add the smaller angles together, they have to equal the whole thing. So again, if I'm adding and I'm doing an operation, I'm going to be doing that with measurements. So I'm going to put little m's in here. So the measure of angle ABD, so that top smaller one, plus the measure of angle DBC, that has to equal the overall angles measurement. So the measure of angle ABC. All right, okay, a couple more here. Midpoint is exactly what it sounds like. It is a point that's exactly in the middle of a segment. So I'm going to use M for midpoint. So if this point is exactly in the middle of a segment, that means this half and this half have to be congruent. So that's what this statement is saying here. Oh, and sorry, I'm going to actually not use M because I'm going to use the letters to match what it says in the definition. So it says if B is the midpoint of AC, so we'll make B the midpoint of AC. So if that is true, then this must be equal to this. So AB, and you can do it one way. So I can either say AB equals BC, or we could say AB with the segment symbol is congruent to segment BC. So either one of those would be fine. But notice the equal sign goes without the segment symbol, congruent goes with the segment symbol. Okay, segment bisector. So you might say, well, let's talk about that word bisect first. Bi is a root word for two. So bisect means it's cutting something into two equal halves, so right in the middle. And you might think, well, isn't B bisecting? Yeah, a point that bisects is called the midpoint, but it doesn't have to be a point necessarily. So I'm going to add some letters here, D and F, to match my definition. So we can have a line, a ray, or a point bisect. So I'm going to draw another segment, AB. And this segment AB is cutting DF exactly in half at M. So this matches our definition. So if segment AB bisects DF at M, so it's cutting DF exactly in half, and the point at which it's cutting it in half is M. So M is the midpoint, okay? All right, then, well, same thing. Bisect means it's cutting it exactly in half, so these two halves must be congruent. So DM is congruent to FM. All right, okay, angle bisector is the same thing. So we have angle DAC. So we learned bisector cuts things in half, and angle bisector just cuts an angle in half. So we have ray AB, so because it's in half, it's got to go exactly through the middle of this angle. So we have ray AB is bisecting angle DAC. Okay, so if it's bisecting, then this angle is congruent to this angle. Okay, so angle DAB is congruent to angle BAC. All right, okay, and that's it for the vocab for these two sections, you guys. Again, pretty heavy on notation. Make sure you got all of that written, and bring questions if you have any to class. All right, thanks for watching.